Just imagine, you are sitting in the comfort of your home, looking out the window and watching the plants sway in the light breeze, while birds sing in the background. It is almost automatic to feel that this scenario of peace and tranquility will always be within our reach. But what if I told you that, in the distant future, all this that we call life on Earth could have an end date? And what's more, that this end will be triggered not by giant asteroids or immediate cataclysms, but by a silent and gradual process of heating the sun, reducing carbon dioxide in the atmosphere, and making our planet less and less habitable. Yes, it may sound scary, but several scientists have already made the decision. The Earth, as we know it, will not be eternal. Are you curious to understand how all this happens? What researchers are predicting and why even microbes can survive longer than plants and animals? Stay with me until the end of this video, because I will explain every detail of this story that has intrigued the scientific community and that will change the way we see our place in the universe. Let's start with the basics. The crucial role of carbon dioxide, CO, for life on Earth. Plants depend entirely on this gas for photosynthesis, which in turn sustains virtually the entire food chain, from small insects to large mammals. However, recent research shows that as the sun becomes brighter and hotter over billions of years, the weathering of rocks in the Earth's crust intensifies, removing more and more CO from the atmosphere. Think of deserts you may know or have heard of, where vegetation is almost non-existent. This would be the image of the planet in an extreme scenario, only on a global scale. Scientists predict that this drastic reduction in CO will be a game-changer for the future of the biosphere, causing plants to perish and consequently leading to a domino effect on all the organisms that depend on them. And it doesn't stop there. A research group led by geophysicist R.J. Graham of the University of Chicago has come out with a projection that actually extends the expiration date of life on Earth. While previous estimates pointed to around 800 million years, this new study suggests that the critical point could arrive in 1.6 billion years, or even 1.86 billion, depending on how climate and weathering interact. Although it may seem like a very distant date, knowing that there is an expiration date for the planet's biosphere shakes our certainties. The sun, with its increasing intensity, not only provides light and heat, but gradually pushes us into increasingly hostile conditions, both in terms of temperature and concentration of gases in the atmosphere. It is almost ironic to think that the same star that makes life possible here also prepares the ground for its eventual end. To better understand, let's break down the concept of weathering. Basically, it is the natural process in which rocks and minerals on the Earth's surface are eroded, whether by the action of water, wind, or chemical reactions. As global temperatures rise, this weathering intensifies and pulls more CO into the crust, removing it from the atmosphere. For those who ask, but isn't this a natural process that has always happened? Yes, it is. However, the constant increase in sunlight accelerates everything significantly, creating an imbalance that can be fatal for plants. It's as if nature was stepping on the accelerator towards a road of no return. And remember, without plants, animal life loses its basic source of food and oxygen. Imagine entire forests withering, crops failing to survive, and the consequent collapse in the food supply. This is the kind of scenario that generates fear, because it brings us face to face with the truth that our survival is intrinsically linked to the health of the planet. However, we cannot ignore the fact that nature is surprising and resilient. Graham's study shows that the relationship between temperature and weathering is not as linear as previously believed. In other words, under certain conditions, The co-removal process can slow down or even temporarily reverse, extending the life of plants on the planet by a few million years. This gives rise to some hope that the Earth can resist a little longer than the most pessimistic scenarios predicted. However, it is important to emphasize that resisting a little longer may only mean a difference of a few 100 million years on a geological scale, which, in practice, does not change the final destination, an Earth that is increasingly arid, hot, and unable to sustain life as we know it. If we look at the planet's history, we see real examples of mass extinction events, such as the one that wiped out most of the dinosaurs 65 million years ago, proving that natural disasters are not fiction, but rather part of Earth's history. One point that draws much attention in this discussion is how different types of plants respond to low levels of CO. According to the most advanced simulations, C3 plants, which make up the largest portion of the world's vegetation, would be the first to disappear, as they require more CO for photosynthesis. This includes trees, essential cereals, vegetables, and practically everything that makes up the largest landscapes of our daily lives. On the other hand, C4 plants, such as sugarcane and corn, can survive at much lower levels of carbon dioxide and can extend their existence for a few more million years. However, even these last survivors have a limit, and when they too collapse, plant diversity will fall to zero, taking with them most of the animal life. It is distressing to think of a world without forests, without the greenery that soothes the eye, without plantations that feed entire populations. But this is the final route in a scenario of a biosphere in gradual collapse. Faced with this future, what would be left? Some scientists are betting on anaerobic microbes, organisms that are less dependent on oxygen and can live in extreme environments. Think of bacteria that live in superhot hot springs or freezing cold glacier. They are experts in survival. And even these microorganisms would have an expiration date, because at some point, solar heating would be so intense that even the oceans would evaporate. Without water and adequate temperature conditions, there is no microbe that can survive. Of course, all of this seems very distant, but these studies bring us to an immediate reflection. Are we underestimating the importance of maintaining the planet's current balance? If global temperatures are already rising due to human activities, we may be, to a lesser extent, accelerating processes that would occur naturally in billions of years. And this could affect not only our quality of life, but also leave irreversible marks for future generations. To many, this talk sounds like science fiction or excessive alarmism. But it's worth remembering that astronomical and geological phenomena don't care about our opinions. They just happen. Just look at planets like Venus or Mars, each with their own extremely different and hostile atmospheres, to get a glimpse of how Earth's future could be radically altered by cosmic forces and the planet's internal dynamics. Some argue that these studies serve not only to better understand our future, but also to guide the search for life beyond Earth, showing that similar planets may have larger windows of habitability than we thought. This type of research inspires space agencies and astronomers to redouble their efforts to find worlds that could harbor complex life, while making us, here on Earth, question whether we are doing enough to preserve what we have today. Real-world examples of climate change are already all around us. In recent centuries, we have witnessed events such as the advance of deserts into once fertile regions, the transformation of agricultural areas into infertile lands, and the extinction of species that were unable to adapt to drastic changes in temperature and water availability. Although these are much smaller changes compared to the billion-year scale predicted by scientists, they show how nature can react when there are imbalances in the carbon cycle. Imagine extending these processes over millions or billions of years, with an increasingly relentless sun and a decreasing concentration of Co. The result is a planet silently heading towards biological stagnation. Therefore, studies such as R.J. Graham's not only outline the inevitable fate of the Earth, but also raise an alarm about how we should deal with current changes. After all, what we do today, in terms of emissions and conservation, also decides how welcoming our planetary home will be in the next generations. Now I want to know your opinion. Do you believe that these extreme future scenarios could change the way we deal with the environment today? Do you think that, even so far away, the fate of the biosphere should be part of our current concerns? Leave your comments below, as it is always amazing to exchange ideas on such profound and highly impactful topics. Also, take the opportunity to like the video and subscribe to the channel if you haven't already, so you don't miss the next discussions about science, the environment, and the future of life on Earth. Thank you for staying with me until now, and until next time.